Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going to go over section 5.8, which is one of my personal favorites, the point-slope form. Now before we learned the slope-intercept form, which seemed to be the holy grail of all formulas, because you had y is equal to mx plus b, and everybody loved it, and they praised it, and they thought it was great, and there was much rejoicing, and everybody was like, hooray! But honestly, I'm not really that impressed with the slope-intercept form, mainly because you have to be on the y-axis for it to work. Well, what happens when you don't start on the y-axis? What happens when you don't start at year 0? I mean, we have lots of calendars that don't start at year 0. For example, the main calendar that we use in the world today wasn't actually started in year 0. It actually started like a couple hundred years later. It's kind of ridiculous if you ask me. But it's, everybody has to have a year 0, I guess. You could consider that your birthday is year 0, in which case we should say that 1982 is year 0, or 1984 is year 0, or even maybe 2010 is year 0, depending on who you are and what year it is. So, what I like about the point-slope form is it doesn't confine me to starting on the y-axis. This gives me a huge degree of freedom. It lets me start anywhere. And what is point-slope form, you ask? Well, it's really easy. It's y minus y1 is equal to m times x minus x1. The thing about this is we need to figure out what this y1 and this x1 thing are coming from. These come from a point that you are given, and it can be any point in the universe. So y1 and x1 come from a given point. So no longer are we confined to the y-axis. Now we can start wherever we want. If we want to start 100 miles from the y-axis, we can start 100 miles from the y-axis. And then we can still graph. And that's the beautiful thing about point-slope form, is it lets us be anywhere rather than confined to a single location. The problem, of course, is that we need to find out how to figure out what our x point and what our y point are from something that's given to us. So let's go ahead and take an example. Let's look at that. Let's say that we are given the point 2, 4, and we want to start at 2, 4 with a slope of -3/2. I know the last time I did -3/2 as a slope, it kind of was really difficult, but we'll see if Mr. O'Neill has improved since then. So, for our point-slope form, we're given the point 2, 4. 2, 4 is always an ordered pair, x, y. Oops, wrong one. At x, y, where the first number is x and the second number represents the y. Except now we're using point-slope form, so these become x sub 1 and y sub 1, respectively. Now when we plug them in, you'll note that we have a minus sign in front of them. So I would say y minus, and then whatever my y1 value is going to be, is equal to m. What's my m? Well, it's -3/2, so let's put that in already. -3/2 times x minus our x1. Now I know there's a lot of parentheses there, but it's math, get used to it. So with all these parentheses, let's make sure that we have the right number. We can color code them. I think I'm going to color code them so that all the numbers that I'm putting in are in the manliest color of all time. And then the second set of parentheses I'll put in black to represent my original formula. So then I look at it and I go, okay, what's my x1? Well, my x1 is 2, so I plug in a 2. Oops, sorry. I plug in a 2 for the x1 location. And then the y1 is 4, so I plug in a 4 at the y1 location. So from the information given, a point and slope, I have just created in point-slope form the formula. This is just fine. Now, most of the time, your teacher will say, no, I want it to be prettier. And I'm like, okay, all right, whatever. Let's make it prettier. Let's go ahead and drop the parentheses. So I have y minus 4 is equal to negative 3 halves times x minus 2. And this would be, of course, the prettier one that's more refined. It's the one that actually took a shower before coming to school. It's the nice one, the one that everybody likes being around. So let's go ahead and see these in action when it comes to graphing, which is, of course, the part that you like the most. Everybody loves graphing, and the sarcasm can be felt from miles away. Let's say that we're given this system of y minus 1 is equal to 3 times x minus 1. Looking at this one, we have two major options. Option number 1, graph as is. And that's what we're going to do first. Graph as is. So to graph as is, we need to find the find the point, and then from the point, use the slope. So looking at this, my slope is equal to whatever this multiplier is. Oh, it happens to be 3. And then I need my intercept, or sorry, not my intercept. I've been doing that one way too much. Now I need my point. Now my point is at x comma y. Well, my x is right with my x, but you'll notice that this is a negative 1. And from before, when we had a positive 2 that we plugged in, it ended up being a negative 2 when we were finished. So I would take the opposite sign. God, I hate that word, but it works here. The opposite sign of what you see in here. So since I see a negative 1 on the inside, I put a positive 1 for my x-coordinate. And then for the y-coordinate, same thing, right? Was a positive 4 with a little negative sign here, so it became a negative 4, so we do the opposite sign and we get a positive 1. So we have our point at 1, 1, and we have our slope of 3. So we go to the point 1, 1, 1, 1, dot, and we use our slope of 3. Rise 3, run 1. Rise 3, 1, 2, 3, run 1, make a dot. My computer will be nice to me. There. And then drop 3, retreat 1. Drop 3, retreat 1. And there is our beautiful, somewhat straight line. That's graphing it as is. Now, I know a lot of people have difficulty with having multiple ways of doing the same thing. They think that there's only one way to do something and that it's always the right way. As a mathematician, I can assure you there are many ways to do many things. There's always another way to do it. Always. You just have to find it. It might not be the most efficient way, but there's always another way. So when I was in the Navy, they used to say there's the right way, the wrong way, and the Navy way. So yeah, there's always at least 3 ways to do it. Let's try this one using option B. The second option, and this is the one that I know you guys will like and I will hate and detest and abhor, is convert to y equals mx plus b. Then graph. I do not like this method. If you guys haven't noticed, I like to get away with doing as little work as possible. I like to be efficient. I like to make sure that everything that I do has its purpose and that I don't go overboard with that purpose. So when it says convert to y equals mx plus b and then graph, I am creating a ton of work for myself. Not only am I creating a ton of work for myself, but I'm also allowing a lot of error to enter into my equations. So let's look at this one and look at how many places we can have an error. So we have y minus 1 is equal to 3 on the outside of x minus 1. The first step is, of course, to use our order of operations. Gemma. Now, unfortunately, we can't do anything in the grouping symbol because they're not like terms, so we've done everything that we can. There are no exponents in this case, except for 1, and that's really boring. So we go on to the next one, which is multiplication. When we multiply something that is being added together by something on the outside, it distributes to each piece on the inside. So here's mistake possible 1, distribution. And this is a mistake I see all the time. And by all the time, I mean pretty much on every test that I've ever given. When we have a distribution portion, somebody messes it up. So we get 3 times x is 3x. 3 times negative 1 is negative 3. And we still have the y minus 1 on the other side. Now next I want to get y by itself. So what am I going to do? Yes, I'm going to add 1 to both sides. And this is part number 2. Moving the y point. This is another section or another piece that can lead to a mistake. I've seen people do this and end up with something like negative 4 over here, in which case I'm like, why did you do that? And they said, but I'm plussing it. I'm like, yeah, but that's a minus sign. That's saying I went to the left 3 spaces, moved to the right 1, and ended up 4 spaces to the left. I don't know how that's possible either, but some people just did it. So remember, opposite signs mean that you subtract. Same signs means you add. Alright, so I add 1 to both sides, and I get y is equal to 3x minus 2. Not 4, 2. And then when we have that, we have it in y equals mx plus b format. So we go to our graph, and we're going to do the same thing as before. We start at negative 2, because that's my y-intercept, and we rise 3, run 1. Hey, look at that. It's at 1, 1. Rise 3, run 1. Drop 3, retreat 1. Draw a straight line through it, and what do we have? Yep, the exact same line as before. However, there were multiple locations where error or mistakes could be made in doing so. So the last piece on this one is, of course, graphing wrong. So I'm going to put that in pink, number 3, graphing wrong, which is possible in both cases. But if you have a mistake here, you're going to have a mistake here. If you have a mistake here, you're going to have a mistake here. The mistakes travel with you all the way to the end, which is why you can have the, quote, correct answer, unquote, and still have something that is totally wrong, because all the mistakes that you made ended up canceling each other out. That's what I call getting lucky. All right. So that is it for today's lesson. Unless, of course, you want to look at one where we take... Yeah, let's take a graph and then write the equation for it, and then that will also show you how much easier that the point-slope form is. Okay, so let's say that we have a graph that starts way up here. 1, 2, 3, 1, 2. And let's say that this is the line. Alright, so from this graph, we're given some information. We can tell that the slope is, let's see, we drop 3 and then run 2. So this would be a slope of negative 3/2. And then we could use any point on the graph that we want. We could use this point up here, which is at negative 1, negative 2, negative 3, and then 1, 2, 3. So we can use the point negative 3, comma, 3. And then in point slope form, we'd have y minus, our y value is 3, is equal to our slope, negative 3/2, times x minus our x value at negative 3. And then cleaning that one up is super easy. We would have y minus 3 is equal to negative 3/2 times x negative times the negative is a positive plus 3. Bam, done. Now, try to do it with y equals mx plus b format, where there's your b. Yes, you have to guess. You have to make an assumption. You have to assume that that's at a half mark. It could be at a third. It could be at 3/4. It could be anywhere in between. We don't know for certain. But we have to guess and we have to assume, versus when you're given a point and you can figure out what the slope is, that makes it a lot easier. So your two options are option 1 on this, to just go with what you've got. The guess the y-intercept and go. So you would say that the y-intercept in this case is -1, 2, 3/2, and then your slope, of course, is still given at -3/2. And then you'd have y is equal to mx plus b, so we'd have y is equal to -3/2 x plus -3/2, and hope that that's the correct equation. Well, it can be tricky. It can be very, very tricky. The other option is to take your point slope form and then solve for y. So yeah, you already had to do the point slope form, so why would you want to do more work? You can do that. You can guess and go, up to you. If it says specifically to look at point slope form, you have to use point slope form. If it says specifically to use slope intercept form, you have to use slope intercept form. If it just says write the equation of the line that does this, use whatever's easier. I would probably use this one, but that's me. I'm weird. I like to not work hard. Alright, so that is it for today's lesson. Let's go ahead and go on to your favorite part, which is before you go. So before you go, and this is going to be, of course, section 5.8. And we're going to be looking at hashtags. Math is fun. Hashtag math is awesome. Hashtag don't you just love this. How about 1 through 15 odd? And then 19, 21, 25, 29, 31, and because I love making sure that you do stuff that is important, let's do 34 and 35. Please note that this 34 and 35, if you don't do it, I'm not going to count it as your homework being completed. So if I was you, I'd probably start with 34 and 35 and then go backwards. Why am I doing this? I am doing this because I care. You guys need help with word problems. The only way you're going to get help with word problems is if you do them. So let's do the word problems. 34, 35. Got to get them done. Otherwise the homework won't count. Or sorry, before you go work won't count. That's it. Good luck and have fun.